Welcome back to my channel. In this session, I would like to discuss the types of DC generator. How do you classify DC generator? DC generator can be classified into two. First one is called as separately excited DC generator. The next one is known as self-excited DC generator. You know, the self-excited DC generator again divided into three categories. They are series generators, shunt generators, compound generators. Even compound generators can be divided into several categories like long shunt generators and short shunt generators. So moving on to further discussion, how do you classify the DC generator? Yes, the main classification criteria is based on the methods of excitation. You can underline this point based on the excitation. Okay, so you can note down based on the excitation. Okay, note down this point, very important. Okay, based on the excitation. So we'll be discussing about this classification individually. So first we'll discuss about separately excited DC generator. Later on we'll come to self-excited DC generator. Also we are going to discuss their significance. Okay. So kindly aware about self-excited DC generator. As you can observe, the basic diagram of self-excited DC generator. So let me show you how does it operate. The main two components of DC generators are number one, armature, number two, field winding. Correct? You can see the armature and field winding. Okay. Actually, in order to produce the magnetic field, here you can see like armature and field winding, both are two separate circuits. You can see two separate circuits. Okay. Armature, which is given over here, and this is your field winding. Now, how do you excite the field winding? Yes, we require a battery or DC supply. Okay, we require a DC supply. Why DC supply is required? To excite the field winding. That means as soon as I provide the DC supply, there is a field current. Now, why do you keep a resistor here? This is because to limit the field current, because we need to control the field current so that there is a potentiometer or a variable resistor. Next one is known as the armature. Okay, armature is the rotating part. We have the brushes, positive, negative, along with the commutator also available, and which is connected to the load. The generated voltage that will be supplied to the load. Okay, so the field winding is provided the supply current is provided to the field winding. Therefore, field current is generated. The magnetic field is generated in the surrounding area. Therefore, the magnetic field is going to cut to the armature. As soon as the armature is rotating, a dynamical induced EMF is produced that will be supplied to the load. So we will be applying the Faraday's law of electromagnetic induction. Here EG is the generated EMF, then the load current and armature current. This is your armature current. That armature and load is connected series. Therefore, armature current is equal to load current. So we can write like a terminal voltage. V is the terminal voltage. Terminal voltage can be written as EG minus IA into RA. If you apply the KVL, you will come to know this. Okay, this is actually applicable after KVL, after applying the KVL. The electric power developed at the armature, that is EG into IA. This is your electric power developed. Therefore, power developed to the load, you can write like the EG IA minus IA square into RA. So therefore, you can take IA is a common factor. Therefore, I can write IA into EG minus RA. Therefore, I can write IA into what is EG minus RA? That is nothing but terminal voltage. This is actually V into IA. So this is regarding the separately excited DC generator. If you use separately excited DC generator, the main drawback is we require additional excitation circuit, and we need additional DC supply to excite the field winding. That is bit expensive. So, and this structure is too bulky. So we are not recommending separately excited generator for the common application. Now I would like to go for self-excited DC generator. What do you mean by self-excited DC generator? Here, we do not require any additional power supply for activating the field. Okay. Here you can see like there are different configuration for the connection of armature and field winding. No separate excitation circuit that you can note down first. First one is known as series generator, DC series generator. In this particular circuit, the armature, this is your armature, okay, armature. This is your field winding. Armature and field windings are connected in cascade or series. That is why it is known as series generator. So the current flowing through the load and the field and the armature are identical because all are connected in series. Here, we do not require any excitation circuit. Separate excitation circuit is not desirable. Okay. So here you can see like armature current that is equal to the series field current that is equal to load current that is equal to I. Therefore, terminal voltage can be written as V is equal to, okay, applying the KVL, Eg minus I into Ra plus Rse, where Ra is known as armature resistance, where Rse is known as field resistance. So, therefore, electric power developed is nothing but Eg into Ia. So, power developed across the load because ultimately we are generating the power, right? So, we need to deliver the power to the load from the generator end, from the armature end, correct? Therefore, the total power developed is equal to, but we can write is electrical power developed minus like the total we can like losses we can consider like the losses. Eg into Ia minus Ia square into Ra plus Rse. I square R loss. You might have heard about that. So therefore, Ia into Ia will be taken as common factor. Eg minus Ia into Ra plus Rse. Okay, so Ia you can take outside. Eg minus Ia into Rs is nothing but terminal voltage, which you already defined. So ultimately, I'll be getting V into Ia, or we can write V into Ia. Hope you understood the concept. You should know the KVL, then basic equation of losses. You should know what is series circuit. Then the concept will be very easy. This is regarding the series generator. Now let me discuss about the DC shunt generator. How do you say this is DC shunt generator? Why? Because the DC generator, armature of the DC generator, number one, this is your armature which I pointed right now. And this is your shunt field. See, shunt field is available, armature is connected here. Both are in parallel. Okay, that is why it is known as shunt generator. Okay, shunt or parallel. Okay, here voltage developed from that EM voltage across the load is equal to the voltage across the generator, terminal voltage across generator. So that voltage will come across the field winding. So shunt field current, anywhere EMF will be generated from the armature side. Okay, after rotating, and you can apply the Faraday's laws of electromagnetic induction and the concept of dynamically induced EMF. Therefore, the armature current you can write like IA because if the generator voltage is getting generated, if the circuit is shorted or closed, current started flowing. That is called the armature current IA. Here IA is getting split into ISH. This is your ISH. Okay, this is important for solving the problems. And some part of current is passing through the load. Therefore, I can write like according to KCL. Okay, the entering current at a junction. Let us call this is a junction that is equal to current leaving from the junction. Okay, ISH plus IL. So same thing we have written here. Please make a note of this. Apart from that, we can write ISH. How do you calculate ISH? Apply the Ohm's law, ISH. Total voltage is V, terminal voltage, divided by RSH. RSH is nothing but resistance offered by the field. Also, we can write the terminal voltage is equal to Eg minus Ia into Rn. Why RSH is not included? Because RSH is we'll be considering the terminal voltage Eg minus Ia into Rn. Okay, we are not considering this RSH here. Electric power developed is equal to Eg into Ia. Here we are going to talk about electric power developed at this particular armature, that is equal to Eg into Ia. Power delivered to the load, V into IL. Okay, V is equal to V into IL. Across the load will be considered load power. Okay, load power. So this is regarding DC shunt generator. Now we'll discuss about the compound generator. So compound generators are two types. One is long shunt generator, another one is short shunt generator. We'll have a brief discussion about long shunt generator and short shunt generator. Okay. Okay. So we'll be talking about the short shunt DC generator. A compound generator means so we have both both series field, both series field and shunt field. Make a note of this. That is why compound generator is the combination of like the series generator and the shunt generator. So here, the series field windings are connected with the armature are shown in figure. So also we can have the shunt field winding. So both series field and shunt field winding, which is connected in this fashion. That is why it is known as long shunt generator. So if I remove this portion, this segment, so this segment is known as, you can see here, this segment is actually the part of shunt generator. If I talk about this particular segment, you see here, this segment is actually called a series generator. This is your shunt part. Okay, this is your shunt part, and this segment is known as series part. So, like a combination of shunt and series generator. So that is why it is known as compound generator. Here, the series field is equal to load current. You can observe here, series field will be. So current flowing through the series field, that is equal to load current because both are in series. ISH you can apply. Okay, ISH is equal to the terminal voltage divided by RSS. What is terminal? What is induced EMF? Now we can write like a V plus ISC into RSC by RSH. So apart from that, the terminal voltage you can compute. V is equal to EG minus. EG is the back generated EMF. IA into RA minus ISC into RSC. Okay, current is different here. You cannot make it as a common term. So the armature current you can write. Armature current is written as so ISH, ISH plus IN. So you can apply KCL. So this can be written as KCL. Similarly, electric power developed at the armature is EG into IA. Power delivered to the load is P into IL. So this combination is known as uh, like we can see like a compound generator. Okay, so you can make a note of this. So this is regarding the long shunt. So we have discussed about like a compound one generator. In that we discussed about a short shunt generator. Now I would like to go for the long shunt generator. The circuit diagram is shown here. So we have like a series field, okay, sorry, shunt field, and we are having series field RSC, and which is having series field resistance RSC. This is your shunt field resistance RSH. See the connection. So this is your long shunt generator. Long shunt. So the series and shunt field windings are connected in parallel with the series connection of series field winding and armature, which is shown in the figure. Look at this. Series field is actually connected with series to the armature. Shunt field as it is in this fashion. This is regarding the long shunt connection. If I talk about the series field current, we can calculate IA. How do you calculate IA? IA is the combination of ISH and IN using the KCL. Apply the KCL. You take this one as a node. Okay, from this you can compute IA is equal to IL plus ISH. Armature current, that is nothing but ISH plus IL, same thing, KCL. Shunt field current we can write like V is equal to C. This is your voltage. Okay, terminal voltage. Okay, because same terminal we'll consider at everywhere. Potential will be same only because it's a shunt connection. V by RSH. Okay, these are the equations which are required to solve the numerical examples and just for the analysis purpose. So make a note of this. Also, terminal voltage, we can write like a V is equal to Eg minus Ia into Ra plus Rc because we have two like series connected winding, series connected components. One is RSC, other one is Ra. RSC means field resistance. Ra is nothing but armature resistance. So we'll be writing like V is equal to Eg minus Ia into Ra plus Rc. So power developed is equal to Eg into Ia. Okay, power developed is nothing but Eg into Ia. Therefore, power developed to the load is equal to V into Ia. This is regarding long shunt compound generator. So we discussed about short shunt compound generator. Here you can see the combination. The series and shunt field windings are connected with the armature. Okay, see in this fashion. Here, the series and shunt field connected in parallel with the series connected of series field windings and armature. That is the combination. You remember this combination. You can remember the combination. Okay, this is regarding the classification of DC generator. Again, the DC compound generator based on like flux addition and a flux subtraction. There are another two types you can divide like cumulative compound, cumulative compound one. Also, we can classify like a differential compound one. Differential compound one generator. Okay, this one also, this classification also you can remember. So this is regarding the classification of DC generator. So let me summarize what I discussed. So in this video, I discussed about the detailed classification of DC generator and the sufficient equations also I have explained. Those equations will be helpful for doing the numerical example. Okay, so connections, then why separately excited DC generator, why we call self-excited DC generator. Self-excited DC generator is like divided according to the connections of armature and the field winding. We have DC series generator, DC shunt generator, DC compound generator. It is divided into short shunt and long shunt. Apart from that, you can divide like a cumulative compound one generator and differential compound one generator based on the flux addition and subtraction. Okay. So these are the classification. If you have any queries, please let me know. Thank you so much for watching this video. Happy learning. If you are watching our channel first time, kindly request you to share, watch, like, and subscribe. Thank you.